Hi, this is Mrs. Chana recording the lab video for the heating and cooling curve of water with Vernier. For this lab, we're going to be using the machine called the LabQuest, which will take data. What you're seeing now is the interface of the LabQuest that we're going to be working with. And we're going to plug in, using this telephone style plug, one of our temperature probes. And you can see that immediately the temperature probe started reading the temperature. So this temperature is showing that room temperature in the air is about 25 degrees at the moment. All right, now we're going to take the stylus that comes with this LabQuest and we're going to change a couple of settings. So you're going to go to mode, and it's time-based. See if I can get that right. And right now it's taking 2 samples per second, and we want to change that to 0.2 samples per second. And that means a sample will be taken every 5 seconds when we do that. And the duration, we're going to change to 900 seconds. So that's going to be about 15 minutes you're going to be taking data. Hit OK down here. And then the temperature probe is taking time-based at this rate for this duration. And it says right here, there's a little green arrow for me to push when I'm ready to start taking data. So where is this temperature probe going to go? This one right here? It's got to be inserted into our sample. So let's make the sample. Here you see we have a graduated tube. We're going to put about as close to 5 milliliters of water as you can get, exactly 5 mils. We're going to read the meniscus there, and it says it's at 5 milliliters. We're going to insert that temperature probe, and we're going to take some data of whatever temperature that water is right now. Theoretically, it should be at room temperature, but let's hit go and start taking data. And immediately our LabQuest starts taking data. You'll see a little red data point will be collected about every 5 seconds. And I'm going to take data for about 200 seconds, and the clock is ticking down. I'm at 15 seconds of data so far. Now it's gone to 20 seconds. So while that's taking the initial temperature, we're going to build a salt water bath. And we want it to be a cold salt water bath, so we're going to put about 150 milliliters of water. There you go. And then we're going to put about 6 or 7 ice cubes in there. And this entire container of salt. Now, one of the things that this salt's going to do is lower the temperature of this water below the freezing point for us. So this ice water will actually get to be at a lower than 0 temperature. I'm going to leave that stirrer in there because I'm going to continue to stir it as I use it to take data. All right, I'm back over to here. I'm about 85 seconds along into this temperature. What do we got? It looks like the temperature is 24.4 degrees Celsius, and that's staying pretty steady. See that? And that makes sense because it's at room temperature. The water's at room temperature. The probe's at room temperature. There's no heat transfer happening. So I'm going to raise this clamp up a little bit and then insert it until this water is submersed in my salt ice water bath. So let's do that next. Okay. Now we see the ice water has come up above the level of the water in my graduated tube. So all of the water inside my tube, whose temperature I'm taking with this probe, is submerged below the level of this ice water and salt water there. So let's take a look at what happened. Immediately the temperature dropped. And we're going to watch that temperature continue to drop for the next 500 seconds. So notice I'm stirring this around so that the water stays a consistent temperature around the probe. And I'm going to move the probe occasionally to let the water inside that tube stir around as well. And as I need to, I'm going to add an ice cube or two to keep the water really cold. This is salt water and ice cubes. And right now, this ice water is pulling heat out of the water in this graduated tube. Let's see what's happening to the temperature. Still dropping. So remain this way. Stir this about every 10 seconds. Stir this continuously if you can. And we'll see you back here after 500 more seconds have elapsed. Okay, I'm back. We're at 500 seconds, and you can see that the temperature has dropped quite significantly. I'm now at about 0.4 degrees C, and I can no longer move this probe inside this container, which means this probe is stuck frozen. So I've now achieved solid ice. So inside my graduated tube, I have ice. So what I'm going to do is lift it up out of the ice water bath so you can see it. All right, what do you got there? Got frozen solid ice. I can't even move this probe. This probe is frozen solid in ice. And so what has happened to our temperature? Our temperature has remained constant. So now we're going to leave it out of the water for another 100 seconds until we get to about 700 seconds. We're going to leave this out of the ice water bath. What's happening during that time? Well, obviously, the temperature in the room, the air in the room, is going to begin to transfer heat to this ice. As it transfers heat to this ice, the probe will start to get loosened, and I'll be able to move it out of the ice that is inside the tube. Now, after about 100 seconds, when we get to 700 seconds on the LabQuest, we are going to drop this into a sample of warm water, where we can try to speed up that ice melting process. So I'll see you back here at 700 seconds. And we're back. We're about 665 seconds, so we got a few more seconds to go before we're going to start warming this up at a higher rate. I have a smaller beaker here for the warm or hot water, and once I've let this sit until about 700 seconds have passed, you'll see that it's starting to melt, but it's not completely melted yet. And so what's happened to my temperature? It is still constant at 0.4 or 0.5 degrees. Want to hit 700 seconds? I'm going to submerge this in the warm water bath. And so this warm water bath is going to transfer heat a whole lot more efficiently than from the air. And we can see that the ice is just disappearing. And how will I know when all of that ice has disappeared? Check out what's happening to the temperature. Now all the heat that transfers from the hot water to my tube is actually warming the water now. And my temperature probe inside my water sample, inside my graduated tube, is rising. And it'll probably continue to rise until I hit 900 seconds. Now, if this water was hot enough, it would continue to rise indefinitely until it started to boil, but it's not hot enough. Eventually, we'll reach an equilibrium temperature between the water inside the tube and the water inside my beaker. And I'm swirling this around to make sure all of the water that's in my warm water bath has a chance to make contact with the water inside my tube. Check it out. My temperature has risen all the way to 27.9, even higher than my original water room temperature was. All right, so we can stop collecting at about 900 seconds. So carry on until you get to about 900 seconds. Hey, we're back. The trial has finished, and you can see that it is no longer taking data because the little green triangle has returned. So at this point, we're going to hit File, Save. And I'd like you to save it right up here, tap, and put your initials and your lab partner's initials and call it Heating Cooling Curve. And then when you're done, you'll hit Done. And then it'll save it right here if you hit Save. And that'll be on the LabQuest until we're ready to come back and look at the data. That's it. For cleanup, you're going to put all of the various waters down the sink. Take your probe, rinse it off. Make sure your LabQuest is powered off. Rinse your probe in the sink with a little bit of distilled water. Take your distilled water container and return it to the wash bottle bucket. Take your empty salt container, return it to the salt bucket, and leave your beakers upside down on your desk. You have to rinse your salt out a couple times. And then take a wet paper towel and wipe anything into the sink and follow up with a dry paper towel. And you're done.